YouTube, what's up? We're going to build some stuff today. It's a Saturday and I love building stuff. Well, mostly because I have a problem that I need to fix. If you're like me and you have an FPV plane that uses the same battery for the ESC and the servos and the rest of the aircraft that it does for the video transmitter, you need to keep all of those high and low frequencies, pulses of DC, you need to keep those out of your video transmitter or they're going to mess with your video. So there's something to do that. And copper tape won't work because the resonances this time are actually moving through the DC current in the wire. So we can't just tape around it and call it a day. We have to build something called an LC filter. An LC filter is a system of resonators and capacitors that detune, basically, mute that, that resonance. It's basically the equivalent of finding a resonating guitar string and then slapping your hand over it until it stops resonating. So what we need to build this is we need a couple of things, and they're actually very simple and very easy to get your hands on. 1N4004 rectifier diodes. You can buy these at Radio Shack. As long as they are rectifier diodes, they'll work. Does not matter which serial number you get. Schottky diodes won't work. Zener diodes won't work. Tunneling diodes won't work. LEDs might work, but don't do it because you might have be burning out your LED because it's not going to have a resistive element. You need two 1500 microfarad input and output caps. You need a 330 microfarad cap. You need a low frequency resonator, which is always going to be the one with more coils because the wire is longer for longer wavelengths. You need a high frequency filter. These are both, I wound these both on a ferrite ring. They're pretty easy to do. And they don't have to be super precise because we're not trying to get exactly one frequency here. We're just kind of slapping our hands across the neck of the proverbial guitar and trying to mute any of the sound that might be there. And then the last thing that we want is we want a PC board to put this all together on. So I'm going to grab my soldering iron and I'm going to show you guys exactly how to build this circuit. Okay guys, so the first thing that we need to do is we need to install this rectifier diode for reverse polarity protection. So if you plug in your battery the opposite direction or something gets messed up, whatever, this will keep you from blowing up your video gear. So basically what you do is you see that white stripe on the diode there? Okay, that white stripe is the cathode, which is the negative side. And we're going to face it, we're going to put the end without the stripe where we would have positive connected for the input. We're going to put the cathode side, which is the blocking side of the diode, in toward the rest of the circuit. And the reason we're going to do it like this is because that will allow positive to flow this way, but if you reverse the current, it's not going to allow it to flow back. So basically, if you connect the battery backwards, it won't make a circuit at all, so it won't blow up your gear. So let's get this soldered in. Even if you have polarized battery connectors, there's really no excuse not to install a reverse polarity protection diode. They're just so easy to put in, and they can save you a lot of trouble if you ever make a mistake. Kind of hard to solder and see if I'm in the frame of the camera at the same time, so I apologize if I keep moving in and out. There we go. Alright. Now like any PCB soldering, it's going to leave these tails. So we've got to cut them off. Like that. Now just remember, the side with the diode is going to be positive. Positive is going to connect on this side behind the diode, or else you won't get the protection. Alright, now what we need to add after the diode is we need to add one of these capacitors, one of these big 1500 microfarad caps These ones, the reasons that we are putting these caps in here is because when you hammer on your throttle, there's going to be voltage dips up and down. That also goes for when you use your servos, whenever there's a current spike. So this is going to even that out as much as it can for this circuit. So the regulator in your 12-volt supply isn't constantly switching back and forth, and your camera isn't constantly switching back and forth, and your transmitter isn't switching back and forth. So this will just help out. It'll make all the other electrical equipment do a little bit less work, which will help keep your video signal clean. So we're going to connect this, which is the negative side, the stripe with the minuses, on the opposite side of the diode. Okay, so find a place where it fits without actually bumping into the diode. Okay, there we go. Now I've got the positive side on the diode, which is correct. We've got the negative side facing away from the diode, which is also correct. So now we need to solder that in. Okay, so there it is. It's soldered in properly. But this PCB does not have traces. It just has dots for the solder to stick to. So what we're going to have to do is I'm going to bend over this tail to connect only with the diode's output. You do not want it to connect to the input, because then it would bypass the diode and there would be no point in putting it there. It would not be reverse polarity protection at all. So we'll add a little bit more solder. And then I'll make sure that this is squished down, and I'll solder it right to the board. Okay, cut the tail. Alright, then we need to keep this from standing up. Doesn't really matter if you do or you don't. I like to just add a little bit of extra structure because I have a ridiculous quantity of solder around. But it also helps out with power handling and keeping this from getting hot during its operation. Okay, so the other thing that we do is we do the same thing to the other side. We lay it down. This is going to be our negative input. So, see that? You get the negative bust over to one side, and then you've got the positive connected through the diode. Okay, good. That's awesome. Next step, we need to install the low frequency ferrite. So that's the one with more wrappings. And it's got a positive and negative on either side. So the first thing we need to do is get the varnish off this wire, and the way we do that is with excessive heat. So you guys can use a match. I'm going to use my heat gun. Turn it up to 825 and then just burn the insulation off. Okay, so we got our inductor ready. Now all we have to do, because this is a non-polarized device, is just make sure the positive and negative basically stay in the same orientation. So we'll install it and then we'll check. Alright, there's one side. Now we just got to pop the other side in. Okay, so let's test to make sure that positive and negative on one side are the same as positive and negative on the other. So the way we test that is we get our VOM here. We set it to a high impedance setting, and then we just check if you get any kind of, if the 1 turns to a 0. So you go from one negative to the other negative. Oops, slid out just for a second. Okay, one negative to the other negative. That's good. Now this guy to this guy. That's good. We want to make sure that it's not cross-feeding, or shorted. That's good. That's good. Okay, so that means that it's ready to solder in, so we'll just go about doing that. Make sure that these wires are tucked in a way that'll stay there, by the way. This guy kept popping out because there's a little blob of solder there from something else I was doing with it. Okay. Like I said, non-polarized, so its position doesn't really matter here. But if you want to make your circuit compact, try to get it as close to the cap as you can. And when that's in, get your soldering iron ready. What we're going to do is we're going to extend the blob of solder down the circuit to only connect to one side, front to back, so both positives and both negatives will not be connected at all. Otherwise that would be a short. And it really helps to have some kind of clamp while you're soldering. I usually use one, but for the benefit of my wonderful YouTube audience, I'm doing this without a clamp so that you can see what I'm doing. Okay, that's good. So you've got one side connected like this. And now we need to add a piece that is what separates this LC filter that I've designed from a lot of other ones that I've seen. We're going to use a second coil. We're going to separate it with a capacitor and a diode so that it doesn't feed back into the other coil. Basically, the reason I did this is because I take it that we're trying to get rid of multiple frequencies other than just low end. So I have a low frequency and a high frequency toroid that will absorb and dissipate various ranges. I mean, they're totally imprecise because this is not a tuning circuit per se. It's just supposed to take any resonance and totally squash it, because all we're trying to get out is DC. So the next thing to install would be the tiny cap. Now that would be the 330 microfarad cap that I have here. You can use another size if you choose, but nothing over about 500. Alright, so we've got our little cap. Make sure that you set it up in front of the toroid like this. Make sure the negatives are the same, or else you will blow up your cap, and that's bad. And you'll have these two guys, these two cap leads, coming out like right next to the leads for the ferrite. Little inductor. So what you can do is you can push, once you get the cap to lock down like that, you can just solder those two together. And that's a pretty easy prospect. Okay, now the other side. Okay, awesome. There we go. Let me just make sure, yeah. It's a good connection. Okay, so we're on our way to getting this finished. We've got our diode, first ferrite, cap, second ferrite. But before we install the second ferrite, there's one thing we need to do. We need to install a diode to protect the second ferrite from resonating the same frequency as that one. Or trying to, or picking up any kind of resonance from it. So we'll take a diode, bend it down like this, point it the same way as the first diode, right like this, and now I got a little overzealous with the solder on one side, so I'm going to have to melt the solder while pushing the diode in to have it come through like that. Okay, good. Just even this out and make sure it lays down on the board properly. So there it is, and now I'm just going to solder it in. Diode, cap, ferrite, diode. Almost done. We have one more ring and one more cap to go. We just barely have enough room for it. Remember, do not bridge the gap. Do not bridge the diode. We want one side to be separate from the other. Okay, there's that. Make sure that there's no connection in between them, which there isn't. Cut those little pigtails, those leftover bits of connector, and that's good. So there's our circuit. Now we need the last one. Positive and negative don't really matter on the ferrites. Looks like we're just barely going to have room for it. Good. Okay. So this is going to take me a second to get seated. I will speed this up for you guys so you don't have to deal with waiting. And I'll take an X-Acto blade and I'll open up these holes so that it'll fit. Okay. So if you're working with stranded wire like this, guys, quick tip, it's probably easier to tin the wire before inserting it so that it doesn't fray. Alright guys, so we're almost done. And if this looks like I installed it on a different PCB, that's because I did. I ran out of room on the old one. So we've got our circuit almost done. We've got the diode, input cap, low frequency toroid, stabilizing cap, diode, high frequency toroid, and now we need the last capacitor. So this is going to be the output end cap. That's going to go right like this, wherever it can snap down. Wherever it has enough room, just barely. Okay. Then, just turn that over. Same process as before. We just lay down the little tails and we solder them in. We want to make sure that we don't short the toroid though, so we've got to just do it to the outermost pieces, the outermost connections, the furthest most connections. Okay, awesome. That's the completed circuit. Let's see if we can give it a test run. Alright guys, so here we're sitting in front of my amp and we're going to test out this signal filter. So I'll directly hook up a tone generator that's running on my computer to the input the amp. Alright, so that's a 250 hertz tone. Let's turn it way up. A lot of gain. Okay. So now let's use the signal filter that we just built to see if we can correct for that. So we'll connect negative to the negative side of the capacitor. And we'll connect positive to the positive side of the capacitor. And the positive and negative outputs are going to be what we connect. So let's see, this is positive, so that's the pin. Here's negative, that's the shield. Let's see if we hear anything. Nothing. Very effectively filtering the 250 hertz tone. Now let's see. That one's still on. So I think we've proven conclusively that this little filter is doing a great job. So that's how you do it. If you want to build one for yourself, it's very simple. 2 caps and a couple of toroids, guys. If you want to see more videos like this one, don't forget to rate, comment, and subscribe.